Picture this. It's 1957.
Right.
You were walking into this massive 19th century brick building situated right on the Aspet River in Maynard, Massachusetts.
Yeah, this old wool mill.
Exactly, an old wool mill. It actually stitched blankets for Union soldiers during the Civil War.
Wow.
And it still smells strongly of like dust and old lanolin. But you walk into a rented corner of this massive echoing space, I think it's about 8,600 square feet, that costs just $300 a month.
Which is just crazy to think about now.
It really is. And you see two young MIT engineers, Ken Olsen and Harlan Anderson.
Right.
They're sitting on cheap office furniture they bought on credit. They've got $70,000 in startup capital. And they share this technological secret that could completely upend the world as we know it. But this is the crazy part. They're absolutely terrified to use the word computer.
It is such a striking visual contrast, you know? The Industrial Revolution's dusty leftovers housing the quiet birth of the digital age. And it's the humble origin of what would become Digital Equipment Corporation, or DEC.
DEC, right.
Yeah. This is a company that didn't just build electronics. I mean, they fundamentally rewired how human beings interact with machines.
Completely.
To understand the scale of what we were talking about here, at its peak, DEC employed over 120,000 people across 80 countries.
That's massive.
It generated $14 billion in annual revenue. It was literally the second largest computer company on planet Earth, worth billions and billions of dollars. And then, quite spectacularly, it essentially just vanished.
And that vanishing act, that is our entire mission for today's deep dive. We are building a masterclass business school case study on what creates success and what creates catastrophic failure in the tech industry.
Right, using the historical mechanics of disruption.
Exactly. We're using a fascinating documentary and a brilliant companion essay about the rise and fall of DEC to unpack all of this. Like, why do giants fall? But we aren't just looking backward here. We're going to take these exact historical blueprints and project exactly what the artificial intelligence landscape is going to look like 20 years from now.
Which is honestly the perfect way to use history. I mean, if you want to understand the future trajectory of massive planet-scale systems like modern AI, you cannot just look at the code.
Oh, you have to look at the business side.
You absolutely have to understand the business mechanics. You have to understand what happens when a scrappy company disrupts a giant, becomes a lumbering giant itself, and then gets completely blinded by the glare of its own massive success.
Okay, let's unpack this, starting right there in that wool mill. I want to talk about this fear of the word computer.
Yeah, it's wild.
Olsen and Anderson get their initial backing from a man named Georges Doriot. And Doriot is essentially a pioneer of the entire concept of venture capital.
He really was.
And he gives them a very specific piece of advice about how to market themselves.
He tells them, and he's very serious about this, whatever you do, do not call your product a computer.
Because of IBM.
Exactly. In the late 1950s, IBM completely and totally owned the concept of the computer. IBM wasn't just a market leader. I mean, they were an untouchable monopoly.
Right.
To tell an investor you were starting a computer company in 1957 was like telling them you were going to build a private space program in your backyard to compete with NASA.
They'd just laugh you out of the room.
Totally. Investors would literally just laugh. So Doriot suggests linguistic camouflage.
I love that. Linguistic camouflage.
All right. So they call themselves Digital Equipment Corporation, and they name their machines Programmed Data Processors, PDPs.
So they basically just sneak in through the side door.
Pretty much, yeah.
But I think for anyone listening today, we need to clarify what an IBM computer actually was at that time, just to understand why DEC's strategy was so revolutionary.
Oh, absolutely.
If you wanted to use an IBM mainframe in the 50s or 60s, you didn't just buy one and put it on a desk. They cost millions of dollars. They were the size of entire rooms.
Yeah. They lived behind these imposing glass walls in heavily climate-controlled environments.
And you didn't interact with them directly, right?
No, not at all. That is the key mechanical difference. Computing back then used something called batch processing.
Okay, can you break down how that actually worked for a user, like mechanically?
Yeah, so imagine you're a researcher. You would write your program, which meant literally punching holes into a thick stack of cardboard punch cards.
Oh, wow. Cardboard cards.
Yeah. And then you would physically carry this stack to a specialized technician.
Like a guard.
a literal priesthood of operators who guarded the mainframe. You handed them your stack, they queued it up in the machine with dozens of other jobs, and maybe if you were lucky the next day, you would come back to get a printout of your results.
That sounds agonizing.
Computing was strictly rationed.
It's like going to a super exclusive, incredibly slow restaurant.
Right.
You can't enter the kitchen. You hand your highly specific order to a very intimidating waiter. You go home, and you wait for them to mail you your food the next day.
That is such a good way to put it.
And if you made a single typo on one punch card, your meal is ruined and you have to start all over again.
That is exactly how frustrating it was. I mean, it was incredibly tedious. But Ken Olsen had noticed a behavioral quirk while he was working on an experimental military machine at MIT called the TX0.
What kind of quirk?
Well, students would wait in line in the hallway for hours just to use it, completely ignoring the much faster, much more powerful IBM machines in the very same building.
Wait, really? Why? What did the TX0 have that the mainframe didn't?
It had a keyboard and a monitor.
Oh.
Yeah, you could sit down and type, and the machine would respond to you immediately. Olsen realized that interactive computing, putting the machine directly into the hands of the end user, was the actual future of technology.
Because the speed didn't matter as much as the access.
Exactly. The speed of the processor didn't matter as much as the immediacy of the interaction.
So DEC takes that philosophy and builds the PDP line. How did that translate into an actual commercial product?
It translates into the PDP-8, which launches in 1965 and completely changes the world. The PDP-8 didn't cost millions. It cost $18,000.
Still a lot, but a huge drop.
Right. And it wasn't the size of a room. It was the size of a small refrigerator. And eventually, it actually fit on a workbench. It was the first commercially successful mini computer.
Huge computer, right.
Yeah, you could put it in a university lab, on a factory floor, or in a newspaper composing room.
So going back to the restaurant analogy, DEC basically invented the microwave oven.
Yes.
You finally had your own kitchen appliance.
Yeah.
You didn't need the waiter or the massive industrial kitchen anymore. You could just cook your data whenever you wanted.
And when you put that appliance directly into the hands of creative people, without rationing their time, you get these unexpected explosions of innovation.
Oh, right, the video game thing.
Yes, my favorite detail from the source material. It involves the earlier PDP-1. In 1962, a group of hackers at MIT finally had direct interactive access to a screen and a keyboard.
So what do they do with this highly expensive scientific instrument?
They spend 200 hours programming and accidentally midwife the world's first video game.
Space War.
Exactly, Space War. And DEC recognized the cultural shift so quickly that they actually started shipping the game preloaded on new machines.
Wait, really? As a feature?
Well, they said it was to test the memory.
That is amazing. I love the idea of serious corporate executives unboxing this highly technical machine and finding a spaceship shooter game on it.
It's hilarious.
But I have a fundamental question about the business mechanics here.
Sure.
They had a great product, this interactive mini computer. But how does a tiny startup in a dusty wool mill not just get immediately crushed by IBM the second they start eating into their market?
That's the billion-dollar question.
Right.
Yeah.
Like if IBM was a monopoly, why didn't they just lower the prices on their own smaller machines and run DEC out of business?
That question gets to the very heart of this case study. Technology alone almost never dictates who wins and who loses. Our sources highlight what they call sub rosa, or hidden currents, the invisible market forces that dictated DEC's survival, and the most vital of those was something called the antitrust umbrella.
Okay, walk me through that. What exactly is the antitrust umbrella?
So IBM was a monopoly, yes, but the U.S. government was heavily policing them. In 1956, IBM was hit with a massive Department of Justice consent decree.
Oh, I see.
Then, a few years later, they were locked into a 13-year monopoly lawsuit. The government basically said to IBM, you control too much of the market. You cannot use predatory pricing to kill your competitors, and you must sell your machines, not just lease them.
So the government forced IBM's lawyers to step in and put a leash on their own sales teams.
Exactly. IBM's lawyers made sure the company kept its profit margins artificially high and played very defensively.
So they couldn't attack.
Right. They couldn't aggressively drop prices to crush a scrappy little startup in a wool mill without risking the government breaking their entire company into pieces. This legal situation created a protective umbrella over the bottom of the market. DEC was allowed to grow in that greenhouse because IBM was legally prohibited from stomping on it.
Wait, are you saying DEC's early massive innovation was mostly just a byproduct of government regulation and defense spending holding back the big guy?
What's fascinating here is that it's not either or. DEC absolutely innovated.
Okay.
Their engineering was brilliant, and their philosophy of interactive computing was dead right. But you have to have both. They built the right product, but they occupied a market space that the government actively kept open.
So timing and structure.
Yeah. If IBM wasn't fighting the DOJ, they might have wiped DEC out in 1968. The lesson here is that market structure dictates technological success. And DEC had another structural advantage, too. Defense spending.
Right. The essay mentions they grew out of Route 128 in Massachusetts, which was just fueled by the Cold War.
Yes, the military-industrial complex and university research labs were swimming in government funding.
Makes sense.
And those specific departments, the engineers, the radar technicians, the scientists, they didn't want to wait in line for the corporate mainframe. They had the budget to buy their own mini-computers.
So DEC was perfectly positioned to catch that exact wave of departmental spending.
Exactly.
So they successfully pushed computers down the organizational hierarchy, from the giant corporate glass house down to the individual department lab.
Yes.
But if they were so brilliant at predicting that shift, why on earth did they stop there?
And that is the tragic turning point of our story. Because DEC absolutely refused to take the next logical step down that hierarchy. Which brings us to 1977.
1977 is a massive year for them. They launched the VX system, right?
Yes, the VX. It was a line of mini computers that unified their entire architecture. It was faster, it was highly reliable, and it was wildly profitable.
Like printing money profitable.
Oh, absolutely. The VX system turned DEC into an absolute juggernaut. It made them billions. They were on top of the world. But that exact same year, Ken Olsen makes a speech at a convention, and he utters a sentence that will essentially haunt him for the rest of his life.
What did you say?
He said, and this is a direct quote, "There is no reason for any individual to have a computer in his home."
Ouch. I mean, 1977, that is the exact moment the personal computer revolution is kicking off.
It is arguably the worst prediction in tech history.
Seriously.
Now, Olsen later tried to walk it back, claiming he only meant computers that ran household systems, like automatically controlling the lights or opening doors. He claimed he wasn't talking about personal desktop computers.
But regardless of what he meant, the company's actions over the next decade proved that they operated exactly as if that quote were their core philosophy. I mean, they completely ignored the PC revolution.
They did. They couldn't conceive of a computer being useful for someone who wasn't a trained engineer or a scientist. While DEC is busy popping champagne over their massive VAGAX mini computers, you have the Apple II coming out. You have the IBM PC. You have the launch of VisiCalc.
For listeners who might not know the early software landscape, what was VisiCalc and why did it actually matter?
So VisiCalc was the world's first electronic spreadsheet.
Okay.
Before VisiCalc, personal computers were largely seen as hobbyist toys. But suddenly, an accountant or a financial analyst could run complex projections on a small screen right on their desk instead of relying on a mainframe and a team of programmers.
Oh, wow.
VisiCalc proved that regular business people needed personal computers.
So the software proved the hardware wasn't just a toy.
Exactly.
So how does DEC respond when it becomes incredibly obvious that everyone wants a personal computer?
Their response is disastrous. In 1982, they tried to release a personal computer called the Rainbow 100.
The Rainbow 100.
Yeah, but they built it with a mainframe mindset. It was premium priced, it was highly proprietary, and it was deliberately incompatible with the emerging IBM PC open standards.
Why would they do that?
Yeah. They essentially designed it as if a personal computer should just be a dumb terminal that connects back to a bigger, more expensive DEC machine.
This is where I struggle to understand the management thinking. The company that literally democratized computing for the department couldn't imagine democratizing it for the individual.
Because it wasn't just a failure of imagination, it was a failure of corporate structure.
How so?
The essay we are using points to the internal culture of Route 128 in Massachusetts. That ecosystem was built on vertically integrated, secretive fortresses.
What does vertical integration mean in this context?
It means DEC wanted to make everything themselves. They made their own chips, they wrote their own operating systems, they built their own monitors and keyboards.
Everything in-house.
Right. You did not use outside standards, and you certainly didn't talk to competitors.
Wow.
Compare that to Silicon Valley, which was emerging on the West Coast.
Very different vibe.
Totally.
Yeah.
Silicon Valley was built on porous networks, engineers constantly job hopping, and open industry standards where different companies built parts that worked together.
Ah, I see. It's the difference between buying a custom molded plastic action figure versus buying a box of Legos.
Yes.
Silicon Valley and the IBM PC clones were building Legos. Anyone could make a brick, anyone could snap an expansion card in, and it all worked together. DEC was trying to sell a custom action figure where only they were allowed to make the accessories, and they were charging a fortune for it.
That is a perfect analogy. The open Lego system of commodity hardware and standardized software completely overwhelmed them.
Makes sense.
And DEC's internal structure made it worse. They used a matrix organizational structure.
I've heard that term in corporate speak, but how did a matrix structure actually function at DEC?
In a traditional company, you have a top-down hierarchy. In a matrix structure, employees report to multiple managers across different product lines.
Sounds messy.
Well, when DEC was small, this fostered incredible cross-collaboration and creativity. But as they swelled to 120,000 employees, that matrix degraded into feudalism.
Here's where it gets really interesting. They weren't out-engineered, they were out-structured.
Exactly.
Well, instead of collaborating, different managers are just fighting over the same engineers.
Yes. It turned into internal warfare. Different groups within DEC were building competing products and actively refusing to share components with each other.
Wow.
They were so busy fighting internally and protecting their high-margin VX business that they couldn't adapt to the cheap, open standard PC market.
And the collapse happens incredibly fast after that. By the early 90s, they are posting massive billion-dollar losses.
Unbelievable losses.
Ken Olsen, the founder, is forced to resign in 1992. Over the decade, they lay off roughly 70,000 people. And then the final nail in the coffin in 1998, they were acquired for $9.6 billion, which was less than half of their peak's value. And the buyer, Compaq, a company that essentially just assembled cheap PC clones.
It is a stunning reversal of fortune. The giant swallowed by the commodity it ignored.
But this raises a major question for the listener. If they were dismantled and swallowed by a PC clone maker almost 30 years ago, why is this our masterclass? Like, why does DEC matter today?
Because of the plot twist in our case study,
Okay.
DEC died as a corporation, but its DNA effectively runs the modern world. The legacy of the company is immortal, but it didn't survive in the org chart. It survived in the people.
Okay, you have to lay this out because reading the source material on this just completely blew my mind. Where is DEC's DNA today?
Well, let's look at the operating system you likely use. In the late 80s, a brilliant DEC engineer named Dave Cutler was building a next-generation operating system for them.
Okay.
DEC's management, who were completely loyal to their old max margins, canceled his project.
Of course they did.
Cutler was furious. Bill Gates heard about this friction, arranged a meeting, and hired Cutler away. Cutler and his entire engineering team literally resigned from DEC on a Friday and started at Microsoft on a Monday.
A whole team just defecting to build the future.
And Cutler took the architectural concepts he developed at DEC and used them to build Windows NT.
Which is huge.
It's massive. Windows NT is the foundational kernel for every modern version of Windows. He also went on to build the software hypervisor for the Xbox and the underlying architecture for Microsoft Azure.
Oh, wow.
A massive chunk of today's global cloud infrastructure was born from a canceled DEC project.
That is insane. And it's not just software either. Their hardware legacy is everywhere.
DEC co-developed Ethernet, the DIX standard, which stood for DEC, Intel, and Xerox.
Yep.
That is the literal networking standard that wires the modern internet. And, we have to talk about AltaVista.
AltaVista is the ultimate example of DEC's tragic brilliance.
Seriously.
In 1995, DEC researchers wanted to show off how fast their new microchip was. So as a pure side project, they built the world's first full-text, web-scale search engine.
Just to show off a chip.
Just to show off.
Yeah.
By 1997, AltaVista was handling 80 million hits a day. DEC's engineers literally invented the modern search engine years before Google existed inside a dying hardware company, and management had absolutely no strategy for how to monetize it. They invented the future, but literally couldn't see it. So when DEC shed those 70,000 jobs, those engineers scattered across the country.
Right.
They went to Cisco, Juniper, Microsoft, Google. They carried the DEC philosophy into the companies that actually built the modern internet.
As the companion essay so perfectly frames it, legacy travels in people, not org charts. DEC's fundamental argument that computing should be human-centric and interactive completely won the war, even as the corporate entity lost the battle.
So what does this all mean? Did DEC actually fail? Or did it just metastasize into the entire tech industry through its diaspora.
I think it metastasized. It's everywhere now.
Which brings us to the final and most crucial mission of this deep dive. We have the historical blueprint. Let's pivot and map this exact pattern onto the future of artificial intelligence. Where is the AI landscape going to be in 20 years?
If we map the DEC timeline to today, the parallels are genuinely uncomfortable for today's tech giants.
How so?
Well, in this historical analogy, today's massive centralized AI models, the frontier models, built by companies like OpenAI, Google, and Anthropic, these are the IBM mainframes.
That makes total sense. I mean, they cost billions of dollars to train. They require massive specialized data centers that use enormous amounts of water and power.
Yes.
And as a user, you don't run them yourself. You submit a prompt to an API.
Let's pause on that, actually. People throw around the term API all the time, but in this context, what is it mechanically?
An API, an application programming interface, is essentially the modern equivalent of handing your punch card to the priesthood.
Right.
You have an app on your phone, you type in a question, and your phone sends that data to a massive server farm hundreds of miles away.
Yeah.
The server processes it and sends the answer back to your screen. You have zero control over the black box doing the thinking.
Exactly. Computing is centralized and rationed all over again, which means the current explosion of smaller, open-weight AI models and specialized edge AI that runs locally. That is the PDP-8.
The mini computer.
That is the mini computer. Right now, the giant frontier labs look at these small open models and dismiss them. They look like toys compared to a trillion-parameter giant. They score worse on standardized benchmarks.
But they offer cost efficiency, privacy, and control. Just like the department lab that wanted its own mini computer instead of renting time on the corporate mainframe.
Precisely. The historical rule is that demand always moves down the hierarchy.
Right.
It goes from the corporate glasshouse to the department to the desktop to the pocket. AI is going to follow the exact same path. It will move from expensive enterprise APIs to personal AI agents down to on-device models running completely locally on your laptop.
But wait, running a massive AI model takes gigawatts of power and massive server farms. Is edge AI really comparable to a personal computer, or are we fundamentally limited by physics here? Like, you can't put a liquid-cooled server farm in someone's pocket.
If we connect this to the bigger picture, you have to separate training an AI from running an AI.
Okay, explain that.
Training a massive model is like reading the entire library of human knowledge to learn a language. That takes massive power and data centers.
Right.
But inference, which is just having a conversation once the AI already knows the language, takes a fraction of the power. And inference chips are getting exponentially more efficient every single month.
It's shrinking.
Exactly. DEC thought the exact same thing about their mini-computers. They thought the sheer computational power required for serious tasks meant computing would always live in a big corporate cabinet. But silicon always gets smaller.
And commoditization always wins.
Commoditization always wins. AI companies banking on centralized server farms are repeating DEC's blind spot.
Wow. There is no reason for any individual to have a frontier model in his home. That is the Ken Olsen quote of the 2020s, and you know someone is probably saying it in a boardroom right now.
They absolutely are. And we can't forget the sub rosa currents. Remember the antitrust umbrella that protected DEC?
Right, IBM being held back by government regulators, creating a greenhouse for the startup.
Look at the AI landscape today. We are seeing massive regulations being proposed. We have export controls on advanced compute chips.
Oh, wow, yeah.
We have sovereign AI programs and intense antitrust scrutiny on the big tech companies that control the cloud and the hardware. We are building a new antitrust umbrella right now.
So history is literally repeating itself.
It is. The incumbents are lobbying for regulations to build a moat around their massive models, but historically, regulatory moats have a funny way of becoming protective umbrellas for scrappy disruptors building open, decentralized networks beneath them.
Okay, let's bring this all together for you. If there was one business school takeaway from this case study, it's this: in technology, having the absolute best, most complex engineering doesn't guarantee you win.
Not at all.
DEC had the fastest chips, they had the most reliable operating systems, and they still lost everything. The winner in tech is whoever intimately understands where the technology is going to live next. And historically, without fail, the technology always moves closer to the individual.
It is the iron law of computing, and it leaves us with one final provocative thought to consider.
What like that?
Think about those tens of thousands of brilliant engineers who left DEC and carried its DNA into the foundations of Microsoft and Google.
Yeah.
Right now, today, There are brilliant engineers walking out the doors of today's massive AI frontier labs. They are frustrated by corporate bureaucracy, by closed systems, by safety boards and computing bottlenecks, but they are carrying the absolute cutting-edge DNA of today's artificial intelligence in their heads.
Oh, man. So if the DEC patterns hold true, the ultimate winner of the AI race 20 years from now might not be a $3 trillion company that exists today.
Right.
It might be a startup founded tomorrow by that exact diaspora. They're going to use today's legacy to build a human-centric, decentralized intelligence that we haven't even named yet.
Exactly.
What if the most valuable AI company of 2046 is currently being founded by two kids renting the modern equivalent of a dusty Civil War-era wool mill?
History strongly suggests that is exactly what is happening right now.
What a place to leave it. Thank you for joining us on this deep dive into the hidden mechanics of disruption. Keep looking closely at the giants of today, and keep questioning the world around you. We'll catch you next time.